Hub podcast. It is October, which means we are continuing ICS Cybersecurity and Cybersecurity Month. We want to again thank the folks at Phoenix Contact for supporting, one manufacturing hub, Vlad and I, as we go and produce this awesome content, and two, the conversations around cybersecurity. It is very important, and if you guys are new here, you will know that Vlad and I are absolutely not ICS Cybersecurity or cybersecurity in any shape experts, which is why we've got Ryan. Which is why we have Ryan, who I will introduce in just a moment. But no, if you guys are new here, welcome. If you've been here before, welcome back. If you are new here, our show will last about the next 60 or so minutes. We'll go introduce Ryan and we'll go ahead and jump in. We like to do our very best to go have conversations in the comments. So if you guys have questions or thoughts, please feel free to go ahead and throw them in the comments. Assuming the Restream gods decide that the comments will come all the way through, we will see them in chat and we'll do our very best to go answer some of those questions for you. Again, very excited for this. And without further ado, I'd like to officially welcome everyone to Manufacturing Hub. I am Dave. This guy down here is Vlad. I would like to introduce our guest today for episode 137, Ryan Heartfield from Exalens. Ryan, welcome to the show. Thank you for being here.
Thank you. And, it's great to be on board. I've been following the show, so I'm really honored to sort of join and have a conversation with you guys. I'm a huge fan, so thank you for that.
Awesome. Thank you so much for joining us and taking the time to speak with us today, Ryan. Before we dive into the conversation on cybersecurity, could you give us a little bit of a background? How did you get started in your career? What was your, different trajectory or different company involvements were like? And ultimately, what are you doing today?
Awesome. Yeah, no, that'll be great. So, I come from the IT world traditionally, which I think is happening quite a lot now. We're seeing a lot of IT security guys jumping into the OT space. But my career has spanned both government, private sector, and academia. I started off working in government, doing network security primarily, security architecture that covered detection and response, security operations. Really, that proactive cybersecurity picture in monitoring data across systems to identify let's say compromise or indicators of compromise and respond to those, and then taking a look at how that we protect and prevent cybersecurity threats and attacks on different networks of different complexity. When I left government, I went to work for Splunk for a little while, and as you can imagine, that spans all industries from manufacturing, industrial, government, all the way to, fintech, etc. And the work I did there was looking at that next level of maturity, which is beyond detection. How do you automate response? How do you orchestrate that security incident response procedure to optimize it ultimately, rather than having manual human operators sitting there diving through logs and then ultimately manually responding themselves? So taking cybersecurity operations to the next level. In my parallel life in academia, I've been working for the equal amount of time, about 13, 14 years, in how to leverage AI. And that might be a dirty word to some people across the industry, but how to leverage AI, which really means automation, to bridge the cyber and physical worlds of industrial systems and robotics for detection and response. And so I did a lot of research about 10 years ago in this space at the University of Greenwich. We innovated in some of those areas to build some novel capabilities in intrusion detection, and I'll talk about that a little bit later. But that led to where I am now, where I'm a co-founder of a company called Exalens, where we are pioneering in OT cybersecurity, but not in the way that you would see in the market today, but where we are looking at cybersecurity in terms of how it should behave in a manufacturing environment by bridging the cyber and physical worlds as part of detection and response. How we leverage the requirement for understanding how processes work and using the same intelligence to inform cybersecurity situational awareness. And so what we've built at Exalens is something we call OT XDR. And what that really means is extended detection and response, whereby we don't just look at, say, cybersecurity telemetry from a manufacturing environment in a network, which you see in the industry today for proactive detection, but we actually upcycle all the existing data that you in the manufacturing environment and process systems are already using for condition monitoring or process automation or statistical process control as part of the cybersecurity situational awareness and analysis. And by building this cyber-physical, let's say, picture, understanding whether or not when disruptions occur, or anomalies occur, whether that was a result of a cybersecurity threat, system fault, or equipment failure. And so we're introducing this idea of cyber-physical security to the industry by leveraging what's already existing in the manufacturing environment.
Let me ask you, Ryan, a follow-up question on those last points. And I guess like I've spent a lot of time on the OT side. So to me, maybe the state of cybersecurity there is the norm. But having you as someone who spent a lot of time on the IT side as well, like what are maybe the particularities you see on the OT side that warrant maybe a different or a special approach when you say, like we're developing cybersecurity for like manufacturing and OT? Like what are maybe like key differences for some of us that don't have those, like both of those like boundaries combined?
I think there's two aspects to the differences. Firstly, how you can monitor security, and then separately what it means to understand about the impact and risk of cybersecurity. I'll start with the first. In the IT space, it's fairly straightforward to get telemetry from computer systems, whether or not it's on the endpoint or from the network. Obviously, we can put in network intrusion detection systems. They've been around for decades, and we can install monitoring systems on Windows machines, on Linux machines, on Macintoshes, and so forth. So it's always been easy, more or less, to get the data we need from IT systems for proactive security monitoring. So that's one aspect, and I'm biased, and I'm talking about proactive security rather than preventative security controls at this point, and we can come on to that in just a moment. But if we talk about the proactive monitoring picture, there's a simplicity there. You can't install antivirus on a PLC, right? You can't install endpoint defense response monitoring on a PLC. It's an embedded system, ladder logic, functional block codes, but you can monitor PLCs, and so that's a very well known thing. We've done it for a long time in terms of condition monitoring. So there's a different approach to be taken there. So firstly, it's getting data from an operational system is starkly different, at least from the endpoint perspective, than it is from an IT system where we can install whatever we like on the system and get the data we need. I'll come back to how we get to data off the endpoint in the process side later in the conversation, of course. As you know, I want to talk about that. But the other side is, but the reality is that cybersecurity isn't really different whether it's an IT system or an OT system. What the difference is the impact and the risk. If we have a compromise of operational technology environment, the impact is safety, right? The impact is physical impact that can impact safety, can bring down a critical supply chain, impact a product, the quality, safety, integrity of it. Whereas, of course, there's impact in the IT space, data theft, data encryption, systems going down. But there's a physical impact in operational technology systems that changes the risk appetite naturally, but also the outcomes of a cybersecurity compromise. And that's why I think the perspectives change, because if you're an engineer who's used to carrying out HazOps in a manufacturing process, understanding really what are the safety considerations, what could go wrong in this process, and how do I prevent them and monitor for them, they're going to be very robust processes that are tested and understood. That is done in the IT space, but it's not the same, right? It's a completely different perspective, and there's a distinction there. And so there's two. That's my kind of view on the differences. Getting data is a challenge from OT, or it has been a challenge historically, and there's a different perspective in terms of risk and impact. Whereas in OT space, impact is significantly higher depending on what that process is and what it's controlling.
Interesting. Yeah, and I guess, do you see maybe the OT space converging in any way towards IT? Like one example that I see is, we're trying to deploy, I want to say like more Linux-based like edge devices, or are you seeing that as maybe like an insignificant amount of those? And I know some PLC manufacturers are also now using like like dual PLCs where it still runs a Windows portion or a Linux portion in addition to the PLC. So, like, I guess, are you seeing that going maybe the IT route where it becomes easier, or you still see that as being like a big problem down the road?
I mean, it's kind of a worst kept secret in the sense that IT systems have existed in OT systems for a very long time. right? If we look at the CNC machining industry, Windows XP machines, Windows CE machines have been embedded in these huge fabrication units for the last 20 years.
Mm-hmm.
So when we talk about is IT and OT converging, the reality is it was always converged in terms of leveraging Windows operating systems on a computing unit to perform some actuation and sensing. Those cyber physical systems, if I might say so, have always existed since we digitized and computerized, for want of a better term, PLCs. We turn them from being mechanical to being computational units. So where I see is the convergence is data connectivity and automation. So there's not really a kind of, okay, we're seeing more of edge compute. It's actually, we're seeing more connectivity outside of traditionally air-gapped networks and systems that were isolated and controlled from a security, safety, and process point of view. And we're seeing data shared, not just horizontally between manufacturing process lines, but north and south, right? From the edge, right? The physical actuation layer, all the way to the cloud. Not just for connectivity and sharing data, but for automation in some cases of the process. Now, the reality of that is that's a good thing. It's a good thing because it allows us to optimize, take data-driven decisions in terms of improving production and manufacturing process, predictive maintenance, trend analysis, so on and so forth. We don't have to kind of go over those benefits to understand why they're going to be competitive advantages in the manufacturing process. But at the same time, what they do is expose interfaces, cyber and physical, into the manufacturing environment that perhaps weren't there before. And by doing that, you've now got to inherit all of the cybersecurity risk that comes from having that connectivity in the traditional IT world. So we have to understand that we are seeing these systems, but they've already existed. It's just how well they were connected and how much automation there was between those systems from the outside world to the kind of the GUI center of the OT network.
I really like that, I guess, clarification of the change in the industry, right? Because again, I have one perception of what's coming into the shop floor, but ultimately, yes, in different industries, especially like you mentioned in CNCs, I think that was already the case for a long time. But it's very interesting to me also, maybe like the other comment, and I'm curious your thought on this, is the fact that we ultimately want to keep our equipment for, I want to say, 30 plus years on the floor, right? And I think it's almost like an unrealistic expectation to place on the manufacturer, because ultimately, let's call it, any manufacturer of equipment is not going to be able to, or is at the mercy, let's say, of Microsoft, who's going to obsolete the platform, no longer support it for all those decades. And so whether we want it or not, we cannot place the blame on the OEM, right? And so it
Absolutely
becomes
not.
very difficult to support.
I mean, my comment on that, and I think I've got maybe it's an unpopular opinion actually, is look at a CNC machine like a Mazak or a Fanuc, $250,000, right? $250,000 of equipment. Now, even down to, let's say, a Siemens PLC S12 71200, maybe a couple $100. The reality is, regardless of the value or the complexity of the machine, there's going to be manufacturing processes in different verticals of the manufacturing industry, whether it's making wooden chairs to semiconductor or vice versa, where these devices are there for decades. And the reality is that we see a lot of cybersecurity hyperbole, if I might add, about these are vulnerable devices. We found a vulnerability in a 20-year-old PLC. Well, go figure, first and foremost. Any sufficiently old system is going to have vulnerabilities, at least from the last 2 decades at least. And if we think about this intelligently and use our common sense for a moment, by the time someone actually gets down to that device, that PLC, and compromises that remote code execution vulnerability, you've got bigger problems, okay? Because what should have happened is that attacker or insider has subverted multiple layers of security to get there. If you've done your network security, your authentication, or access control right, and obviously not everyone does, but let's assume that you've taken the defense in depth approach. Therefore, running around like a headless chicken, we've got a vulnerability in our PLCs, what are we going to do? We can't patch them, they're 20 years old. It's kind of like, well, you can't replace them. If you take them out, perhaps you're going to bring the entire factory down. There's not replacement parts. They can't be patched. And also, is it going to be a financially viable approach to take? The short answer is no. You're going to have to take a step back and go, well, actually, we can't change these devices very often. And even if they were patchable, it's really difficult to patch them because then bring the process down. Maybe it's oil and gas, right? Never turns off. And therefore, you build security backwards from that. You build your security around it. You build a shell around it and multiple layers of the shell, so that by the time you get to that vulnerability, you should have caught that cybersecurity threat risk way beforehand if you'd followed cybersecurity best practices. One other point I'll add on that, Vlad, which is, look, let's say we get to the vulnerability. I'm now sitting in front of a PLC that supports Modbus. It's communicating Modbus. I'm going to try to exploit a really obscure remote code execution, or I'm just going to send a Modbus packet saying, do this. Because Modbus just does what I tell it to do, right? There's no authentication. There's no integrity checking. And by the way, PLCs, robotic arms, and HMIs are still being sold and brought out now supporting Modbus. So you've got wider factory compatibility. So it's not being phased out. The reality is what cybersecurity vendors are saying is, okay, let's build the overlay security to protect that vulnerable protocol in a more secure channel. So I think I agree with you, and from a very convoluted response, that we need to be pragmatic about that vulnerability and patch management challenge around software bill of materials. I think most manufacturers will have no idea what to do with it. And think about cybersecurity as, how do I protect this soft layer, which was probably going to stay soft and vulnerable for quite a long time, by being sensible about how I look at my security architecture.
Look, I've got tons of follow-ups, but Dave, what are your thoughts on this?
I appreciate that. I was going to steal Vlad's line, and it is Vlad's line on this show, Ryan, is I just have so many questions. But he gave us that, and I will also kind of mirror that comment of I also have a bunch of questions, a bunch of follow-ups. I guess kind of just to take us back a little bit. You talked about cyber physical security. I don't think we've had that conversation on this show. Can you define it for the listeners who may not know what that is, please?
So when we talk about cyber physical security, what we really mean is, am I talking about cyber physical security in terms of a cyber physical system? So let's just first describe what a cyber physical system is. It's a computing system that is able to physically control or have a physical impact in the outside world through a computing logic, whether it's distributed or locally. And so it's more an academic term that we're now using more readily because marketing, where we've seen more connectivity and automation between cyber physical systems at a local level or wide level. So a PLC, for example, could be considered a cyber physical system. A HVAC system, which consists of PLCs and actuators and RTUs, can be considered a system of systems or cyber physical system of systems. And the idea is to appreciate where that cyber aspect, again, this is a word which used to be called information technology or security, depending on where you come from, is about understanding the interplay, because that allows you to understand how the system works, the dependencies between it. In what way does the computational process have a dependency on the physical process, and vice versa? In what way can the physical process affect the cyber process in a system or a system of systems? And flipping that, in what way can the cyber system affect the physical process in a system or a system of systems? So when we look at the security of that, I'm not going to go into prevention and controls, because that's a quite a large discussion. I'm talking about proactive security. What do we already do in the factory? We monitor the process of whatever we're building, whether it's at an endpoint level, PLC, or a wider process level, whatever we're producing. But that now, and for a long time, and even more so as we connect and automate, is now a cyber physical process. I have a PLC, for instance. It'll have an operating mode. It'll have input outputs on electrical signals driving motors and actuators. The operating mode is a cyber unit. It's telling you what is the process mode that it's in. It's a computational metric. And then the input output might be driving, the rotational speed of a motor, which is a physical, RPM is a physical metric, or it could be temperature, right? Sensing, for example. So I have a cyber metric and I have a physical metric. And traditionally in condition monitoring, what we've done is we've monitored temperature, we've monitored vibration, we've monitored input outputs on actuation and sensing, and that's for process control, and it's physical, and that's because we want to identify when the temperature exceeded a certain threshold, because maybe that was a safety problem or it was a quality issue in the process. Safety instrumentation systems would look at those things to enact a kind of fail safe, or maybe it's because we want to see how we can optimize our process. and engineers would go in and they would put, what's the threshold for high and low, and seeing where that process variable, which is a common term, sits. But what we have ignored is those cyber metrics, how the systems function at a computational level. And cyber physical security says, okay, let's upcycle both the physical process variable data, both the cyber metric process variable data, combine it to understand how the process is working at a cyber physical level for anomaly detection and root cause analysis. So, for example, if I'm monitoring a process, a cyber physical system on a cyber physical level, I can tell by doing a number of intelligent things what was the root cause of an anomaly. Was it a cybersecurity threat, for example? Was it a system fault? Or was it an equipment failure? And the way that I can do that is by saying, what is the pattern of activity on the cyber metrics in relation to the activity that's occurring on the physical process variables in combination at the same time? If I look at one or the other, I can't get that root cause analysis because I can't build those heuristics across that. I'll give you an example of a heuristic, Dave, where let's say I'm going to use a CNC machine. Its execution state is available. So it's available to start running a program. But then its spindle speed is, going at 10,000 RPM. Well, is that spindle speed normal for that execution status? And the short answer might be completely not, right? It should only be at that 10,000 RPM when the execution status is in active mode. It's running the program, the fabrication process. So by combining those two pieces of information, we can say actually there's either a misconfiguration of the process or something nefarious is going on. It's certainly not equipment failure. We know that for sure. It might be a system fault. It could be a cybersecurity, situation. And then we can take that data and combine it with other cyber metrics from the same machine or other machines in the process to build out that pattern of activity and say that I can see from a cyber physical perspective that this pattern of activity is almost certainly brute force input output on the PLC compared to someone just uploaded the wrong program. But you cannot do that alone by just measuring the process variable at physical level. You can't do that alone by just looking at the cyber data, right? The operating execution status. You need to combine it. And that's what cyber physical security is. And I should add at this point, and I know I'm really elongating this answer, is it's not just useful for cybersecurity, right? It's useful for engineers, process automation engineers, because they care what the root cause is. Because if it's equipment failure, let's go and fix it. If it's a cybersecurity situation, they know that they can take precautions, engage with IT security, so they can do any containment or quarantine or remedial actions that they need to perform as a result. And that's the approach that Exalens have taken in looking at that. And by the way, and I know that you're interested in this area as well. All this data already exists. Manufacturers are already collecting it. It's already in the environments. And perhaps I'll stop there to answer what that looks like and another question.
Well, no, I appreciate that. And I know Vlad and I have had this conversation. We certainly want to get into how you go collect that information and how you kind of bridge some of that IT/OT gap. I guess I think we probably have a couple of questions to kind of finish the previous train of thought before we go jump in there. And I think one of them goes back to that kind of really compelling comment that you have of basically by the time a hacker or a black hat has gotten to the PLC, we have so many other problems, right? And I think one of the maybe large differences between talking about cybersecurity that we do every October and lots of the other conversations we have is that in cybersecurity, you have to accept some amount of risk, right? It is impossible to mitigate all of your risks. And it certainly has eked Vlad and I out through the first, dozen times we've said that and have had this conversation. But at some point, you have to accept some amount of risk. So having said that, when you go talk with customers, is it very much let's go build those layers on top on more kind of IT centric cybersecurity tools before we go start monitoring, or is it we're going to go start monitoring and we're building the layers on top? What are I guess from your opinion, from the cyber physical standpoint, what are the correct first steps, or what are the correct steps for a medium to large end user to take to help to secure themselves?
So I think first I'll talk about the perspective that we receive back from discussing how this technology can help teams. We get a lot of traction from the engineers themselves by understanding that this data alone is gonna help them in their existing day job, right? So they can get better visibility of their processes, better understanding of how the process has independencies on a cyber-physical level and how it interacts with other systems, so that when things do go wrong, they're not spending 2 days trying to work out that someone unplugged the wrong thing from the wrong switch. And this is a true story, by the way. I won't talk about company names. There was a glass manufacturer I was talking to where they had 2 days of downtime in their process simply because someone pulled a cable out of the switch and put it into the wrong interface, which has a different VLAN. So the entire process went down. So first, it's about visibility, that actually we say, okay, the first step is, do you understand your process? Do you understand the systems involved? Half the time, there's not even the visibility to answer that question. And I don't mean that at just a network level, because obviously network monitoring and network asset identification is a huge area of OT security that I'm sure I can talk about, but others can and probably will talk about as well. But there's visibility about the dependency at the process level. It's all well and good knowing your assets, but how do you know what the dependencies are between them? And those dependencies, what dependencies matter as a result, and therefore what to monitor and to prioritize when you do receive alerting. And that's a discussion that we often have, which is, okay, you're an SME. You probably didn't even implement your production line. It was probably some integrator. So you don't really know necessarily all the systems involved. You might know some aspects of the process naturally because you're looking after your production process. So it's a discovery of not only your network assets, that's one. You have to do that if you don't have a grip of what is in your factory. But then actually, can we establish what is important about your process? Do you understand your process? And if things went wrong, what's important to monitor? And that's what the discussion we often have, Dave. You know, we do it for safety, right? It's a no-brainer. Health and safety, we know exactly we should know exactly what's going to happen if things fail most of the time from a safety perspective. But do we know what's important in the process data if things go wrong? And therefore, okay, I'm not going to monitor, I'm going to use a CNC example again, sorry, the spindle, because the spindle is always doing weird stuff. It's so noisy, we can't learn anything from it. But we do care about current and ampage, because that shouldn't exceed a certain thing. And okay, we can measure that data. So building a picture of process visibility is super important in terms of cybersecurity at cyber physical level for securing your environment. Because no matter how much network visibility you have or asset understanding you have, which is by the way, that is usually the first step, I might add, you then have to move on to, do I understand my process? And by understanding my process, prioritize the criticality of the devices involved in that process.
And if I can follow up on that, Ryan, how do you do it at scale, right? So I'm aware that there's a few chemical companies in the world, some of the top ones, that are trying to use graph databases in order to be able to create those links automatically. And it is a very, very difficult challenge, right? Because I think there's something to be said about being able to, let's say, link a spindle to the state of the machine, and something else to be said about, let's say, a tank overfilling because there's a valve, like 5 tanks downstream, or like a temperature being a little bit too high over the set point, and it becomes very difficult to infer those relationships. Like, so I'm wondering if there's any like breakthroughs on the AI side that allow that, or how would you, or are you doing some of that manually right now? What does that process maybe look like?
I'll talk about it generically and then say actually how Exalens approach the problem and what we do in our technology. The reality is that what's important in a manufacturing process is maintaining a level of explainability, so that when things happen, when you want to understand the process and respond to anomalies in the process, as an engineer, process automation analyst, whatever the title is given in the factory, you need to be able to read that information and understand what's going on. So the more dimensions there are, in the example you gave, to the interactions between systems in the process level, the more difficult it is to interpret what on earth is going on. This happened, this happened, this happened, this happened. Okay, brain explodes. So you have to minimize. I mean, it's all a balance. It's always been a balance, which is minimize the dimensions of those learning those relationships in the process to the extent that you can take action on that data. Because it's all well and good having a finite state machine of relationships in a process that looks just spectacular, and it all goes red and like Dave's Christmas lights in the background, right? But the reality is that you can't action that, and therefore if you can't action it, it's not useful information. So the idea is that, okay, if I can look at smaller dimensions, maybe 2 or 3 dimensions of understanding process relationships in a pairwise manner, perhaps, or a I can't think of the word for three, but ultimately, you know, in a small tree manner with a small dimensions, then it's easy to understand. For example, that the temperature changes when the execution status changes, and this causes the rotational speed to change. That's probably as far as you can go for explainability to a human to go, okay, when something goes wrong, I'm going to run off and turn it off because it's going to explode, right? I'm being dramatic, but you get the point. That's kind of the approach that we take at Exalens. We build finite state machines automatically through AI for both stateful and continuous variables. So if you say stateful variables, we'd say something like categorical, like execution status, operating mode, whereas continuous, I'm going to go back to vibration temperature. And we say, okay, what is the relationship between the change in temperature or the behavior in changes of temperature when execution status changes? And learning that finite state machine, but on a small level of dimensions, allows you to build detection models, like anomaly models, on top of those to say, okay, I've got a model that says we know when, if the execution changes, what the temperature and the speed of a spindle should be. And when we generate an anomaly through the AI in that way, it's interpretable, it's understandable, because it's not, you know, it's not AI going, I've seen these 4,000 relationships, anomaly. Okay, it needs to be interpretable so the engineer on the shop floor can do something about it. And to take that approach, you know, there's a number of ways you can do that at AI level, and obviously that's a whole different conversation. But it's about simplifying it at a smaller dimension to make it usable. Because and I talked about academia, we've been doing this for quite some time, these really complex relationships to learn the process and then do anomaly detection. But the output of every single research paper you'll ever see is anomaly, no anomaly. Well, that's as useful as a chocolate teapot in the real world. You know, and I feel really strongly about that. If you said to an engineer, there's an anomaly, they go, where? Don't know, there's an anomaly. But if you said there's an anomaly because the execution status said ready, but the spindle was running really fast and the temperature is going off the charts, you can take that action with context in your mind and perform, you know, either a safety procedure or a process inspection procedure. And so that's the approach we use. But the finite state machine analysis still requires, you know, AI to kind of support the automation of linking to say this changes and this changes and this changes. And that's how we can use AI, and that's the way we use it in Exalens.
Interesting. Yeah. And again, I'm curious, maybe like, can you infer some of those relationships automatically, or do you always need like an SME from that domain and maybe that like machine or equipment to specify what the link is? Because again, like I know there's a lot of difficulty for, I want to say, all sorts of manufacturers from small to large to, as you said, like a lot of them have that data. Some of them just have it sort of, I want to say, like wasted, let's say, like on the PLC. Some of them actually send it to like a data lake or a database, whatever that is. And then ultimately the challenge is then like going through those large amounts of data and making those connections. And again, I think that there's a lot of experts on the data side that cannot always make the link back to the shop floor in order to like connect those dots.
So, I mean, first answer the first question. We do it automatically in our technology without knowing absolutely anything about the process. In fact, that technology we've developed is completely process agnostic. It knows absolutely nothing about the process. It just treats it as a data science problem. If for want of a better term, we call a mini data scientist doing the job of what a data scientist does inside the technology. But why is the first question. Well, there are analytically consistent approaches that data science always takes for these kind of problems. And I won't delve too much into detail, at least to say that the reason most manufacturers collect this data and do nothing for it, because you need a data scientist to go, okay, what's the process I need to take to understand the data, to model it, to do some we call it EDA, right? But data and exploratory data analysis, and then go, okay, what models am I going to use to measure this type of aspect of behavior, or at least understand these two data, a piece of data are highly correlated in some way, and then go, okay, in that case, can I understand an aspect of behavior for these two data points through an anomaly detection model? And that's all. I mean, I could talk forever about all those different intricacies in terms of analyzing data and building machine learning models to generate insights, whether it's for anomaly detection or predictive maintenance forecasting. But what does that actually really mean? It means you need data scientists in your business. Well, most manufacturers or SMEs, 90% of them in the world or more, do not have IT security folk on the bill, right? Let alone a data scientist sitting there ready to plumb through all this data. Only the apex manufacturers might have that kind of, budget and resource, and they do that. But the reality is that the data science field, in terms of analyzing, and this isn't unique to manufacturing data, I might add, any type of data, could be financial data. There is a systematic process that is used always. And if you don't overcomplicate the data science problem, I mentioned dimensionality, if you simplify it down, then you can use a consistent approach each time, which is identify its continuous data, identify its stateful data, I normalize that data, I correlate that data to build these pairwise relationships, and then I apply specific model contexts, so aspects across that data. For example, am I measuring if this is high when this is in this state, or is the sequence of behavior abnormal? And the process of doing that at data science level is quite analytically consistent if you use AI to do that. And we've managed to do that in such a way that doesn't require data scientists. It's completely automated for you. So even an SME can leverage technology without having to, get someone from Harvard who has a PhD in, deep learning to do so. But I think there is an important lesson to be learned about the approach that we've taken, and understanding the approach that's taken in that data lake example you gave, Vlad, which is it's still useful to get all that data in one big bucket and do some really high level analysis and use deep learning for forecasting, but it's not useful for low level anomaly detection. It's good for that really rich long-term view, which requires a team of data scientists to do the modeling. If you want to have real-time, usable, actionable anomaly detection for process optimization or fault detection, minimize the scope and you can automate it through AI without a data scientist. And I think that's kind of not spoken about enough. We don't see that in all these tools that are getting promoted, that actually you can automate this. You don't need a team to do it for you. You just need the data and acquiring the data. And obviously that's the next step. How do I get the data?
Gotcha. Dave, what do you think?
I guess I think many things. I think first, I think it's really refreshing the concept that you guys have, Ryan, specifically in relation to the, hey, if we just say there's an anomaly or no anomaly, and we don't explain it in a way that a normal process SME is going to understand, it is basically a chocolate a tea kettle, right? Like it is yummy and fun and novel to begin with, but at some point I'm going to want a second cup of tea, which is what I'm currently on today, and I'm absolutely not going to get there. So I think that's interesting and refreshing. I love the concept, and I feel like it's something that I would like to spend, 15 hours digging into as to how you guys are able to go run basically agnostic process data through something in order to be able to go understand this. And then after I have like some inkling of an understanding, my question is going to be, Ryan, why does if you guys have figured it out, why, what is so novel about that? But I think that is a separate second conversation.
Sure.
I've got some more questions, but first we've got some people to thank. We want to thank Phoenix Contact for sponsoring this month of OT ICS cybersecurity here on Manufacturing Hub. And with that, we want to wish them a happy 100th anniversary celebration, which is absolutely phenomenal. The mainstays of Phoenix Contact M-Guard product family, models 2100 and 4300, get major upgrades, now with gigabyte speeds. The flexible devices provide an accessible path for segmenting and securing your industrial network. The firewall, VPN, and NAT features ensure that all your networking needs are met. Products are in stock and certified according to IEC 62443-4-1. The Phoenix Contact cybersecurity team also has a major upgrade announcement. They offer IEC 62443-2-4 certified services. These services include asset documentation, secure network architecture, as well as a consultative advice on best practices for your system. And again, we want to thank Phoenix Contact for sponsoring this and wishing them a happy 100th anniversary for this. You guys absolutely should know Phoenix Contact, but if you don't, they produce future-oriented components, systems, and solutions. We've talked about electrical controls with their PLC Next. We've talked about networking and automation. And if you guys have somehow not managed to see that, please go back to, any of the 100, or no, not 100, but certainly 20 or 30 episodes. We've talked about it here on Manufacturing Hub. Again, thank you to Phoenix Contact for their support in this and their continued help in bringing these cybersecurity conversations forward. Ryan, I'd like to go back And we talked about how you collect the process data, and we talked about how it can be used for different things, including process optimization. I do want to get into that, but before we get into that, I kind of want to ask this IT OT convergence question. And I feel like you talked about it a little bit before. I feel like it's something that we have to bring up every time we talk about cybersecurity, because if you don't have the IT people on board for most of these solutions, they're not going to succeed. And so I guess the question becomes, before you can go through and feed all of this process data into your models, before you can go through and look at process optimization and anomaly detection, you have to get access to this process data. So what does that, I suppose, process look like for you guys? And is it an easy conversation with the IT? Is it conversations that are a bit difficult? What does that conversation typically look like for you guys?
Actually, it's not the IT team typically, it's the OT team that provides access to the data, because at least if there is such a demarcation in the organization in the first place. So for example, this data is already being collected in SCADA systems, in DCS systems, in intermediary gateways, in PLCs themselves, in data historians, as part of maybe existing condition monitoring. Therefore, the challenge isn't often asking IT for the data, because the data actually resides in the OT network if it's not already being forwarded to a data lake like Vlad mentioned before. So it's actually a conversation to the OT team, which is, are you even collecting it? Which most of the time you are, but perhaps not all of what you could be collecting. It's, it's in a SCADA system somewhere in a room, or an engineering workstation in some of the more SME environments. But usually there's an element of that data being collected. Otherwise you have no visibility of the process at all. So that's a little bit worrying. And therefore you go, okay, well, can we have that data, right? Because you're using it for process monitoring, or maybe basic condition monitoring. Can we have it for cybersecurity as well? If I said cybersecurity, usually it's like, well, what use is that to us, the OT team? But we don't want to have new connectivity to our systems. They're all very well implemented and static. Nothing changes. That's just how we like it, right? But the reality is that you go, well, what if I could tell you, by you giving us that data for cybersecurity monitoring, we can also tell you when there is a process anomaly in your system without you automatically, or predictive maintenance situation weeks before it actually occurred. And all of a sudden the OT team's like, I mean, obviously that makes sense, right? We can get better at how we manage the process. Once that data is exposed from these systems and shared with a server on the IT network, it's just a matter of sending it to the location, right, where it's going to be modeled and processed. The IT team is never been, and I don't want it to sound like OT versus IT, because it's really not, Dave. It's just that it's as I said right at the beginning of this podcast, it's about connectivity and automation. If you're not connecting and sharing the data already, that might be a cultural change rather than a technological change in the business. Often it's more a cultural change, because data is usually being sent somewhere from the OT network to somewhere. And so that's where we see most of the conversation happening, which is there's a lot of IT already in OT. So it's not this kind of OT convergence is a fallacy in some ways, theoretically, or at least philosophically. It's where's the demarcation point of where you're controlling and looking after your operational systems, and where's the business network or wider systems that are not controlled as part of that, and who has control of those, who is the authority for them, and who is establishing that mediation of connection and automation between them. And by the way, in some cases there isn't, right? It's complete flat network, and those are the nightmare scenarios. So and by the way, in some cases the IT team might be responsible for the SCADA systems, because there's a real, you say convergence at a technology level, there's a real blur in terms of roles now, and that depends on the manufacturing sector. So it's really hard to say, oh, I'm an OT person, I'm an IT person. Certainly at the process monitoring level, but we find it's in those systems where we have to get the hearts and minds of those existing use cases and users. Say, let's expose it. We can get greater upsell of this data and greater benefit for you in your existing process monitoring.
Let me, if I can follow up, Ryan, on that same thought, and maybe ask a philosophical / cultural question, which I think you probably are in a lot of these conversations. I've certainly been in them a couple of times. But going back to the example, of the PLC, or let's say there are vulnerabilities on the OT side, I think we all kind of know there are some, but ultimately, I think more and more of them are being exposed to, let's call it, management. And so I want to get practical in the sense that, let's say a facility understands that there's let's call it more risk than they originally thought, and they ultimately summon the OT engineer and are tasking him to figure out, well, what are we going to do about this, right? And so I wanted to get your take maybe on, is it, try and figure out on the OT side what needs to be done? Is it call IT and have like IT create a wall on top like we discussed? Is it call the OEM and try to put some maybe like ownership on them? Like I want to have the conversation maybe from the kind of like department slash human perspective of what we can do to address maybe some of these concerns or risks, and also maybe like what does the architectural changes look like, right? Maybe it is just a firewall upstream like on the IT side and they configure it and that's all great, like, but I want to get your thoughts maybe on what usually transpires in
It's a really
those rooms.
complex question, Vlad,
Yes.
and I'm sure you're aware of that, which is I hate to say this, it kind of depends on the organization and how they have built their own, let's say, not hierarchy, but demarcation of responsibilities and roles in the business. And it changes from SME to a very large enterprise, very mature, where there's complete separation of duty, where, for instance, the OT engineer would not perhaps be responsible for establishing the security, but would work with the IT security team to identify these are critical systems. These are what we need to protect. If these are affected, all hell breaks loose. And therefore, working with the IT security team should one exist to establish how are we putting preventative control, monitoring controls to reduce that risk, right? To reduce potential compromise or even impact of system faults, for example. In other cases, though, it's the same person, right? So they're kind of the many-hatted engineer, where I sometimes feel this is kind of not an impossible task, but an unfair ask, to say, well, by the way, can you secure the OEM system, which is supported by the integrator that comes in once a month with their laptop and their USBs and subverts all the security and plugs straight into the network? It's like, well, that's what is always done. Why would you change that? And now we have to put in security policy. There's an element culturally of we've always done this. Why are we changing it? But also, when you're asking us to change it, it's a really complex picture. So I think there's a role of OEMs and integrators having a continuous conversation, particularly with SMEs and medium-sized manufacturers, where they're supporting their systems, of helping them understand and improve cybersecurity. Particularly, if there isn't those resources internally in the business, which often they may not be. And as a result of that, building awareness, I think that's what I would like to see. I'm not saying it's necessarily happening. Maybe it is happening in some cases. But ultimately, if you've got those relationships with OEMs and integrators, and they're supporting your process systems, and they're saying, okay, we're going to sell this new product for data collection as well, by the way, guys. Well, okay, what's the security implications? And educating if there isn't that capability in the business already. But ultimately, it could be that many-headed OT engineer. It could be the separation of duties between systems. And I've seen very, very mature organizations and some scary scenarios where it's a little bit kind of maverick and all over the place. But it's not one person. It cannot be. It's a really challenging requirement to understand the full implications of the operational network and the systems involved and the process involved, and then all of the controls you need to put around the network side. I make it sound like an impossible task. It doesn't have to be, but there has to be collaborative tasking in that between the integrators, the OEMs in the system, as well as the OT engineers and IT teams.
Yeah, and I mean, like, look, I like that answer because I think ultimately it is a very difficult, I want to say, like, question, but I feel like there's not enough discussions around this topic, and a lot of times, at least from my experience, the ball sort of gets passed around because we don't understand each other's not necessarily boundaries, but I guess limitations would be like the word I would use, right? Like as we discussed, let's say the OEM is simply almost has their hands tied because they cannot update a system, but the OT engineer is tasked to, like update or patch the firmware, let's call it, of the PLC. And sure, you can go and find a patch that will address some vulnerabilities, but then not others. And because of the lack, I guess, of the communication across those departments, it makes it very difficult to figure out, like, what are the steps, right? Like, what
Yeah.
can we go through as an organization to, I guess, maybe first of all, like, assess where we are at, what the risks are, and then like who needs to do what in order to get us to the state where we would like to go, right? And I guess again, like I said, I was in vague, I want to say, discussions of all those steps, but there doesn't seem to be like a very clear and I know there's a couple of frameworks that attempt to describe it, but not necessarily something that I could give, an OT engineer that starts worrying about these, let's call it threats or vulnerabilities, to present either to their managers or whomever
Well,
at the facility.
I mean, I think you've hit a really good point. There's IEC 62443, which is a framework. And again, it's a framework. You have to implement certain controls and meet certain requirements. And that's, it's done well, it's robust. The reality is, though, it's a framework, it's a compliance framework for standard. Actually, this is part of the content, so I'm not skipping ahead, guys, but it's a vital point. Where there is a framework that the Idaho National Labs have introduced to the industry called consequence-driven cyber-informed engineering, and that methodology challenges the engineering teams, the process automation engineers, IT teams working in OT networks, to take the adversary view of how could you attack this environment, and in what way could you create impact and disruption, and by doing that, as a result, you end up, you end up looking at, for example, how to prioritize the consequence of certain actions and attack scenarios, looking at the systems and seeing interdependencies between them, targeting parts of that architecture. So, okay, these are the bottlenecks. This is where you need to implement specific safety controls and cybersecurity controls, and then putting in place mitigations as a result. And that's the link there. So there is this model, and I think this is something that engineers will have an affinity to, because it's using that engineering mindset, which they probably would already be using at the process level and at the safety analysis level as well as part of the production. And that is less, say academic, that's the wrong word for it, but it's not a massive compliance document that says tick box, look at this, tick box. It's actually take that mindset from an adversary point of view, which you probably already took when you were looking at how the process could fail catastrophically because of a physical phenomena, and implement to prioritize where the attack can come from. Okay, what systems, what are the interdependencies? Okay, what are the controls, and therefore what are the mitigations? And I think I really love this from Idaho National Labs. I think it's great. There's a lot of support for it, and I hope the audience will have a look at that after this call.
I really like that. Like last year, I remember suggesting looking at a process from the other side, like what would it take to hack into a facility, and it looks like these are my kind of people that take that approach, and there is some, I guess, like science to the madness, so to speak. So I'll definitely look through it. Appreciate it.
Interesting.
Dave?
I guess let me kind of take this last topic and move it slightly away from cybersecurity to some of the process optimizations. And I want to kind of tell a brief story that one of our former guests, Dave Eifert from Phoenix Contact, told on episode 103 of what some of the process upgrades that Phoenix Contact Germany was doing. I think it was last year when they were looking at energy monitoring. And I guess long story short, they took approximately 100,000 of the IO that they had, and they used somewhere between 3 to 5% for the biggest pieces of machines. And they monitored the energy, and they were able to go reduce energy, I think somewhere between about 10 and 20%. But then they took the exact same data, they gave it to a data scientist, and then they were able to increase throughput, I think, an additional 10 or 15%. If you guys want to listen to that, go check out episode 103 with Dave Eifert for that. And I guess I tell that story, Ryan, because you told this very compelling story of, hey, we can go use this process data and we'll go give it to our AI, or what'd you call them, kind of like mini data scientists already built into the platform, and we'll go find some process improvements or potential process improvements. And Vlad and I talked about this after the prep call. I think it's a really compelling thought. Can you tell us a little bit more about what that looks like, please?
In terms of how we get the data, or in terms of the process itself?
In terms of the, I guess we understand how you get the data, right? You guys have the data. So what does the process look like, and perhaps what do some of the outcomes look like for the groups that you work with?
So I think the first thing is, once we've acquired the data, it's about establishing what data do we believe is important to measure. Now, from you can take a big bang approach. At least now in our system, it's if someone selects all the data because they don't know what data is useful, then we have to go across data and learn what its behavior is. So there's an element of baselining, always an element of baselining, certainly for anomaly detection. Baseline the data and see what its behavioral change is across a process. And by the way, if it's an ice cream factory, maybe they've got different flavors of ice cream, right? So maybe different recipes change. So what's normal changes at different times of the day or randomly. So identifies any data that would change or add randomness into the process for it to change. Doing that baselining process and understanding that then allows, from a data science point of view, to say what's useful data, what represents data that's useful, and what's stuff that doesn't change or is so noisy it's just not going to be useful to learn any signal in the data. Then as a result of that, getting rid of it and then building models automatically across different aspects of the data. And that can be, and this is a really key point, what's an aspect? It's what is that data doing which would represent something that we understand? For example, what's the rate of change? For example, the acceleration in this data, high or low? Simple things like, is it extremely high? Is it extremely low? Is this transition between states, is that normal? Is the time it's taken to go from one state to another abnormal? Things that we really understand, and building models on those contexts and aspects. And then as a result, once those models are built through the baselining, allowing them to trigger when those thresholds are met based on the learned data, and feeding those as an output and linking them together to build a tree, a visual tree of activity. And that's kind of the process that we use. I mean, we've got some paintable approaches to do that and automate it, but it's really intuitive, because if you could do that as a human, you would, but it's too much data to do it with, right? Because that's the kind of approach that we take. We get data, we make sense of it, we build a story out of it, we build context to it, and we understand the pattern of activity. And we try to codify, for want of a better word, that process so that it's as closely as possible to what an analyst would do when trying to get the outcome and understand the anomaly detection, but automated at machine speed.
Interesting. Vlad, what are your thoughts on that?
I can only tell that it's extremely complex, because I know how difficult it is to, I think there's like different tiers of complexity, right? Because ultimately, like our minds can easily understand, like, let's say like a set point deviation, right? Like if you have a tank level and it goes over by 10% or under 10%, okay, like that's easy enough for us to understand. Same, let's say if there's a temperature that we need to get to, we also understand those deviations. But once it starts getting to, let's call it like integrals and derivatives of, how it spans over time, then it becomes.
That's a really good point. One thing I didn't mention is we don't present the information as statistics like at a mathematical level. This is a standard deviation of 0. whatever. What we do is we describe a metric in something you would understand. So the aspect, right? This is an abnormally high. This is a rate of acceleration that's very slow, and the system explains to you what it learns. So none of it is like a black box AI. The interesting part is everything the system learns, it tells you about. So when you get a report that says, I learned all these different metrics about your system, and therefore when an anomaly does occur, let's say it is a false positive, because they can occur, right? That you can then say, oh, this is what I learned. I'm going to baseline this anomaly so it updates what's learned automatically. And so you still have a role as a human operator in tuning the system, particularly if it's noisy. And so what our thesis has always been, if you want to enable and empower engineers, you need to give them information that's usable. I said this obviously throughout the podcast. And doing that means explaining exactly what the system learned. If you can't explain what it learned, then how can you trust it? For example, if I asked an engineer as a result of an anomaly, go and fix his system, but it was false positive, after 2 goes, they're never going to look at the information ever again. But if you empower them to tune it, then they're going to have control over some of the decision making the anomaly detection takes. But you've taken away all of that hours and hours and hours, or days and months of data science effort, and allow them to be involved at the process where they're most effective. Understanding the process, tuning it where it's required, having actionable information.
No, and it's very interesting, right? Like my comment was less so about it not like it being presented in a complex way, but I'm thinking of potential like use cases, and I guess like the most basic example that comes to mind is if I have a tank that's filling with a certain, I want to say, ingredient, depending on the batch, then I could use that rate of change of the level of the tank to say, for example, if it's not changing as expected, then maybe my flow meter is faulted, or maybe the infeed of the product is not correct, right? So maybe there's some blockage of the pipes or what have you. But I guess it's very like, I'm thinking of how you would reconcile that math, because again, like I've never seen like the rate of change even, let's say, like plotted on, let's call it like on HMI. It's always just a level, and ultimately I know you
Yeah.
can collect it, but I'm just thinking of like how you would want to process that and make those like dots so that you don't just give the rate of change, but you say like, well, because of this and this, here's like a faulty flow meter, here's, you know, like a broken
Mm,
valve or what have, you know what I mean? Like I'm kind of trying
yeah.
to think
I
of.
guess let me jump in and ask the question, Ryan. Would you guys, in theory, come up with the potential issue of a faulty flow meter or a broken valve, or is the outcome it's filling abnormally slow or filling abnormally fast, as you had previously described?
The state we get to at the moment is that there is the rate of change anomaly,
Yep.
potentially linked to another anomaly, like the flow meter hasn't changed its status, or
Yep.
there's some parameter there. And we say in combination, and we visualize this to you, both the graph of the anomaly and the linkage of the events from the same
Okay.
process. And we say this is very likely a process malfunction.
Okay.
But we wouldn't say necessarily it's the flow meter, or just that there's a faster flow through the pipe, through the pipe feeding the tank, because there's not you've got to be, if you say this, you've got to be extremely confident it is that, but you've given all the information to very quickly find out. So usually it will take you hours. You're going to now be able to check fairly quickly in minutes or seconds, because you know what was involved, what the anomalies, what happened first, what happened next, and what is really that behavior representing at a kind of categorical level. Is it a system fault? Is it equipment failure? Is it process malfunction? So we give you that much information, but ultimately you go in and saying, okay, what's the flow meter? May in some cases will require some more inspection. But look, if you can increase the response time, or sorry, decrease it by 80%, that's 80% or more of reduction in impact, and that's where
Yes.
that's where we start, and you can go on from that and improve accordingly.
And to me that makes sense. To Vlad's point of calling out a faulty particular item, I feel like that would be one, exponentially more difficult, and two, take probably a bunch of process knowledge either at an individual facility or a bunch of process experts as they're building in that. But I think it's interesting, and I will say, folks still listening, that when Ryan and I first talked about this in the early part of the year, he's like, "Hey, can I come on and go talk about cybersecurity in ways that perhaps we've never discussed before?" And I would like to thank you, Ryan, because I feel quite confident that we've checked a bunch of the conversations that we have not had in the past. And I don't think Zach Stank is in the comments, but he was yesterday, or I'm sorry, last week, and he was asking our guests, he was asking, hey, can we use AI for that? And man, I feel like we really missed the opportunity to maybe Zach will do a reaction video for us, just talking about how the artificial intelligence is working. But Ryan, this has been fantastic. Thank you so much. I do want to ask you the questions that we ask everyone at the end, and longtime listeners will know that my first most favorite question to ask our guests is to predict the future. And so, Ryan, what do you think that the future of cybersecurity or the future of ICS cybersecurity looks like?
I'm going to say a really kind of maybe a strong statement. OT cybersecurity dead. Cyber physical security is the future.
Okay.
So the future of cybersecurity is cyber physical, and whether we like it or not, and that will help get to a stage where we can result and build self-healing systems. And that's where I see this is the future going. If we have cyber physical security and monitoring, we can work towards self-healing, self-optimizing processes, and that's where I see innovation occurring in the future.
Interesting. I like that. I like big, bold future predictions. So thank you for that, Ryan. Second question, and I know you teased it out a little bit, is we love some content recommendation. And I know one of your points is that content is where we find much of kind of this new information, because by the time a book gets published, it's almost certainly outdated. So on that side, Ryan, what sort of content recommendations do you have for us?
So two, I've already said about the content-driven cyber engineering. There is a lovely book that was recently, it's a white paper combination of research over the past 1 year by Dr. Marina Crotterfield, called Industrial Control Systems, Engineering Foundations and Cyber Physical Attack Lifecycle. If you want to look at cyber physical security and cyber physical attacks at both an academic, industrial, and it's quite deep in parts, this book is fantastic. I would recommend anyone read it. And then finally, if you haven't heard of MITRE ATT&CK, ICS, so MITRE ATT&CK is a way of describing cybersecurity in terms of sort of detection taxonomy. There is a specific version for industrial control systems that allows you to look at the common attack vectors, techniques, and tactics that are used, and it provides a nice overview of where threats can occur, what the attack vectors are, and I'd recommend having a look at MITRE ATT&CK ICS for that.
Awesome. Thank you so much for that, Ryan. I will say to Tobias is in the comments asking where you can sign up for an evaluation of the solution. Tobias, we'll go drop links to Exalens, and if I see you're on LinkedIn, you should be able to go connect with Ryan on LinkedIn for that, and we'll be sure that someone reaches out to you after the show with links, etc. as well. Thank you for the question / comment, Tobias. Ryan, thank you so much for that. We'd love to ask for some career advice, and it's very rare. I'm thinking back on the number of academics that we've had on the show, and I think you said you spent more than a decade in academia. I know we've had a couple of doctors on the show, people who have gone through the process of getting their PhDs, but not a ton of academics. So you probably have a bit of a different piece of career advice, but we love some career advice for folks looking to get in or get further into ICS cybersecurity, please. Absolutely.
I mean, I've been both on the academic side and the industry side, right? So I've kind of got an optimistic and cynical view of both. Which kind of sounds bad, but what I would say is, you have to learn by doing. And when it comes to ICS cybersecurity principles are usually the same, at least at the let's say in terms of protecting data level. But the only, there's not really a mature academic body of education for ICS cybersecurity at the moment. There's not many courses about. So learn by doing. There is a fantastic amount of resources online, building your own test beds. And I say this to all students, whether you're doing standard IT cybersecurity, computer science, you're interested in ICS, you're an engineer, maybe even thought about cybersecurity, download, these fantastic projects through CISA.gov, where there's looking at network monitoring, Modbus simulators, and build a little test bed and just get some hands-on and try to understand these systems, how OT systems work, PLCs, and then attack them, right? See what the vulnerabilities are and learn by doing. This day and age, we can all go on courses and get certifications in education, and I'm very much a proponent of academic research and education, but learn by doing. Please gain the skills, because we want people to come who've got those scars, right? The stresses of getting something working and learning how it works in practice. And that's what engineering is about, right? It's also trial and error and understanding a system physically. And that would be my recommendation. Learn by doing, build some test beds, and use the Exalens Community Edition to do the monitoring over it.
I love that. No, thank you so much. I feel like we get a lot of learn by doing. I feel like we get a lot of learn by doing, especially on the practitioners of the OT cybersecurity. So thank you so much for that, Ryan. And then the last question is who should reach out if people are interested to learn more about Exalens? Kind of how can our community and the listeners today help you?
Just reach out to us. Like I said, we've got a community edition, so if you want to get hands-on and play around the technology, it's accessible by anyone to download and install on any of your test rigs, and join our Slack, right? Join our Slack group and reach us on LinkedIn, myself, my colleagues, and let's start a conversation. Whether or not it's about Exalens technology or just about this problem space in general, we're extremely interested in having a conversation. So LinkedIn, email, website, we'd love to speak to you, Slack as well.
Awesome. Thank you so much, Ryan. And thank you everyone for hanging out with us again today. I will say, if you guys are on LinkedIn, which is where the vast majority of our listeners and commenters are, please feel free to go ahead and connect with Ryan and myself and Vlad and follow Manufacturing Hub. It's all in the event that if you guys are watching this, you guys currently have access to go press a couple of buttons and connect with us. That is the best way to go follow along. Thank you so much to Phoenix Contact for continuing to sponsor the Manufacturing Hub show and the greater support of the community. And I will say, if you guys have made it this far on any of the platforms, please go like and subscribe and share. Ryan, I tell people to do it every week, and people continue to do it. And so as long as people aren't tired of me asking them to do it, I will continue to do it. But until next week, we'll see everyone soon. Thank you. Bye-bye.